Jai Hind friends, myself Dr. Sachin Jain, Associated Professor, Department of Computer Science and Engineering. In the series of lecture of compiler design, today's topic is code optimization. So what is code optimization and the type of code optimization, that is machine dependent optimization and machine independent optimization, we will discuss in this lecture. So what is code optimization? Optimization is a program transformation technique that tries to improve the code by making it consume less resources in terms of CPU or in terms of memory, just to deliver the high speed. So code optimization is the process of improving the code by either using the less resources in terms of CPU or it's in terms of memory, just to deliver the high speed. In optimization, high level general programming construct are replaced with very low and efficient program construct. And in code optimization process, we must follow the three important rules. First rule is that output code must not in any way change the meaning of the program. So meaning should not be changed when we are talking about when we are doing something inside the program. In respect of code optimization, its meaning should not change. Optimization should increase the speed of the program, and if possible, the program should demand less number of resources. So resource usage should be less in number. Optimization itself must be fast. It should not delay overall compiling process. So when we are doing optimization, then it should not delay the overall compiling process time. So it should be very fast. So there are two types of code optimization techniques, that is machine independent optimization and machine dependent optimization. So in this machine independent optimization, compiler takes the intermediate code and transform a part of the code that doesn't involve any CPU registers or absolute memory location. So in machine independent optimization, there is that part of the code that doesn't involve CPU register and memory location will be changed. So we will not change this part. We will change only the part of the code that is apart from these two. So for example, in this code, like here do curly braces open, item equal to 10, value equal to value plus item, while value less than 100. So this part of the code that is coming inside the while loop, we are just putting this value outside the loop. So this item value equal to 10 is written here outside the loop. So this is only changing the program, but this is not affecting any CPU register or absolute memory location. This type of this type of change is called as a machine independent optimization. Another type of optimization, machine independent optimization, is loop optimization. So it is machine independent optimization, and here we are changing something inside the program that is written either inside the loop. So machine independent optimization technique increases the program execution speed by decreasing the overhead of the loop. So we are changing inside the loop here in this technique, and just to reduce the overhead of the loop. So since it is the most time of the compiler spent during the execution of the loop, so reducing the number of the instruction inside the loop, it will improve the program running time, and it will help to execute the program faster. So first technique that come inside the loop optimization is called as a loop motion. Loop motion is also called as a frequency reduction or loop invariant. So in this technique, we reduce the number of lines inside the loop by moving some statement outside the loop. So when we write something outside the loop, uh, then this type of technique is called as a frequency reduction or loop invariant or code motion. So for example, these are the previously written code. Here, some part of the code that is written inside the while loop will be written outside this while loop. So what are the part? Like this statement, x equals to y plus z is written outside the loop x equal to y plus z, and the rest program is very similar to the this one. So when uh, we are calculating x equal to y plus z, and y and z value are fixed, then why we are writing this value inside the loop? So we will just put, if this value is constant, then we will just put this statement outside the loop. It will reduce the overhead of the while loop. Loop fusion or loop jamming is another technique of loop optimization, and it combine when we will combine two or more loop that have the same index variable or number of iteration, then this type of technique is called as a loop fusion. So when we will merge two loops that have same index variable or same number of iterations, then this type of technique is called as a loop jamming or loop fusion. So let's see an example of this. For example, here there are two loops. Here index value I, and both have same iteration 10, 10. So why we are running these two loop when we can do the things using the same loop or a single loop? So we will just merge these two loops into single one, and these statements written inside the loop will be written inside the single loop. So this technique is called as a loop fusion. Loop unrolling. So loop unrolling is a technique that transforms the loop, and in this technique, number of jumps and tests can be optimized by writing the code without changing the meaning of the code. It reduces the number of iteration and increase the program speed by eliminating loop control instruction and loop tested instruction. So how we can do? So in this example, we will see how we can perform loop unrolling. Here integer I equal to 1. Here the two array, while I less than 100, we are computing this one. So in this example, what we are doing, the integer I, the same code is written here. The variable to array is written here. I less than 100, then again this one is written here. Now what we are doing, AI equals to BI and I plus plus here. So what we just write the repeat statement here 2 times. So what will be done? The things will be divided into reducing the number of iteration. So if we will write these statements again, then it will reduce the number of iteration 100 to 50. So this technique is called as a loop unrolling. Now, machine dependent optimization. So this is another technique of code optimization that is done after the target code has been generated and when code is transformed according to the target machine architecture. It involves CPU register and it may have use absolute memory location rather than relative references. Machine dependent optimizer put efforts to take maximum advantage of machine hierarchy. So machine dependent optimization technique is also called as a peephole optimization. So it is a type of optimization that is performed on a small part of that's why we are saying it peephole, a small part of the code, and it is performed on a very small instruction segment of the code. So when we will perform the optimization on a small part of the code, then the technique is called as a peephole optimization. So small set of instruction or small part on which peephole optimization is performed is called as a peephole or a window. It basically works on a theory of replacement in which a part of code is replaced with the shorter and faster code without changing its output. And as I've told you, this is type of machine dependent optimization. So first technique of peephole optimization is redundant load and store elimination. So for example, it is also called as a redundancy elimination. So for example, if I'm writing a code y equals to x plus y, I equal to y and z equals to I. So in this code, I value assigned to y and z value assigned to I. So z value when assigned to I, why we are not writing directly here? So y equals to I equal to y, z equals to I, then I directly refer to the y. So we will replace this z into the z to the y. So this is called redundant load and store elimination. Strength reduction is the another type of optimization technique of peephole optimization. For example, x equal to x into 2. So we can write x equals to x, y equals to x into 2 to y equal to x plus x or y equal to shift 1. So here plus is replaced, star is replaced with plus operator or star is replaced with shift operator. So shift operator always takes less time or it is more optimized rather than using the multiplication. Similarly, the division operator is replaced by a shift operator. So this is called as a strength reduction. Simply algebraic expression. For example, a equal to a plus 0, a equals to a into 1, or a equal to a divided by 1, or a equal to a minus 0. These all the type of examples will not affect the calculation of a. Multiply by 1, it will not affect, it will be divide by 1, it will not affect it, subtract 0, this will not affect. So what the need of writing these? Replace slower instruction with faster one. For example, if I'm writing we are adding something, addition 1, addition or subtract 1, we can replace addition 1 with the increment with r, or subtract we can write decrement inside the register r. So this is called replacing the slower instruction with faster one. So both the instruction are slower one and we are replacing it with faster one. Dead code elimination, the part of code that are not in use, will be removed from the code. That's called dead code elimination. So dead code elimination, to improve the system performance, resources are free and less memory will be needed when we remove the dead code. So how we can remove the dead code? So in this example, we will see the part of code that is not in use. So for example, here here uh, here we are writing return C, and this part that is written outside the C will never reach, because when we write a return statement inside the program, that should be last statement. So this is called as a dead code, because this part will never use. So when we write return C, this part will not ever never used, so we will remove it. This is called dead code elimination. So that's all about the code optimization. Thank you.